So in this problem we have no friction, a large 2 kilogram mass is connected by a string that hangs over a frictionless massless pulley to a hanging 1 kilogram mass. So I'm going to call the 2 kilogram mass big M and the 1 kilogram mass little m. And we're going to plug some numbers in here in a second. So I'm going to define my coordinate system with y pointing upwards and x pointing to the right. And I'm going to draw a free body diagram for big M right here and for little m over here, with Newton number 2's right underneath. So the first thing to realize is if big M moves to the right with acceleration a, which it will, then little m will move downward with that same acceleration a. They're connected by this string. And so the free body diagram shows two canceling vertical forces. So we'll concentrate on the horizontal force. And Newton number 2 says big M times A is going to be the net force in the x direction, which is T. The free body diagram for little m is the net force is T minus mg. And since the acceleration is down, minus m times a is equal to T minus mg. Negative sign here is required for bookkeeping. And so if I take the T from here and I plug it into this equation, I get minus ma equals big Ma minus mg. If I bring the mg over on the left, I get plus mg, and I bring this minus little ma over on the right, I get little ma. And so that gives me this if I factor the right side, and then I can solve for a as little m over big M plus little m times g. That's the acceleration. Now I can take this and I can plug that in here to get an expression for the tension. The tension is big M times little m times g over big M plus little m. So let's plug some numbers in here. First of all, the acceleration is going to be 1 kilogram, that's the value for little m, over 2 kilograms plus 3 kilograms times 10 meters per second, using easy numbers for the acceleration of gravity. And so this is, that's 1, excuse me. 2 kilograms plus 1 kilogram in the denominator. So this is 1 over 3, so it's 10 thirds meters per second. That's what A is equal to. In decimals, that's equal to 3.33 meters per second squared. And how about the tension? The tension is 2 kilograms times 1 kilogram over 2 kilograms plus 1 kilogram. All of that multiplied by 10 meters per second. And so that's 2/3. That's a 10 right there. 2/3, and so it's 20 over 3 newtons. Kilograms squared. I have kilograms squared here divided by kilograms. So this whole thing gives me kilograms. Kilograms times meters per second squared gives me newtons. And so 20 over 3, so what is that? That is 6.67 newtons. That's the tension. This is the acceleration.